In this lesson, we will revisit repetition structures or loops with a focus on counted and nested loops. After studying this lesson, you will be able to code a counter-controlled loop, nest repetition structures, generalize the formula for determining how many times the innermost loop in a group of nested counted loops will execute. Hi, I'm John Beck, and in this lecture we're going to take a look at loops, counted loops specifically, and nesting loops when we put one loop inside another. So let's try and wrap our head around why we might want to do that. Let's start by looking at a checkerboard. Okay, and if we look at a checker or a chessboard, we'll notice it has 1, 2, 3, 4, 5, 6, 7, 8 squares across in a row, and 1, 2, 3, 4, 5, 6, 7, 8 rows down. Okay, so we could also think of this as a Cartesian coordinate system where if this was like one of the quadrants, make it the number 1 quadrant, the upper right hand quadrant, then this would be square 1, 1, and this would be square row 1, column 2, square row 1, column 3, square row 1, column 4. If we went up 1, it would be row 2, column 4, row 3, column 4. And so each one of these squares could be addressed individually using those coordinates like in a coordinate system. Okay, so we could identify each one. So if we wanted to make a task that walked to each one of these squares in turn, row 1, column 1, row 2, column 2, or row 2, column 1, etc., we could say, well, let's walk it row-wise, or let's walk it column-wise. But what we would have is a pair of tasks, one inside the other. One task would be to walk the row across, and that's a generalized task because it doesn't matter what row we're on, we would walk a row across. The other thing we would have is a task that needs to advance the columns or advance down the columns. So we walk this first row, and then that's the end of a loop. 1, 2, 3, 4, 5, 6, 7, 8, we've done that loop. Now we need to go down 1, so we're now in the second part of an outer loop, and we're going to walk that loop 1, 2, 3, 4, 5, 6, 7, 8 again, and then down. So one task is to walk across the row. The other task is to advance down the column. Okay, so first we walk the row, then we advance down the column. We could do it the other way around and walk down the row, or down the column, excuse me, and then advance across the row. That would be another way to walk it. Either one would be fine. But you can see what we have is a pair of tasks, one wrapped inside the other, one being to finish the row or the column, whichever is our smaller task, whichever we define as the primary task, and the other is to advance the row or advance the column, so that in the process of working through each iteration for each minor and major task, we visit every square in the system. Okay, so we might use that in game logic. If we have a checkerboard or a chess game and want to look at all the locations and what pieces is in there. Is it an empty piece, or empty space? Is a checker in that space? That kind of thing. There's lots of reasons we would want to check that. Check for a chess move. Check to see if a win has been detected. That kind of thing. Okay, so fairly common task in programming. Let's see what that might look like if we wanted to generate the output in the coordinate order. 1, 1, 1, 2, 1, 3, and then etc. down to 8, 1, 8, 2, 8, 3 through 8, 8. What would that look like? So in order to do that, I've set up a little list box here. And list box is handy because you'll remember that as we add items to the list box, they start at 1 in the list index and go up from there. So as we add rows to be displayed in the list box, we'll start at 1 and then go to 2 and 3 and 4, all the way down to 8, which was the dimension we chose that corresponds to our checkerboard or our chessboard. Okay, so what we're going to do is we want to display, bring up a little notepad here. Let's say we wanted to display visiting those squares on the checkerboard. And let's start with row 1 and column 1, and then go to 2, 1, and then 3, 1, and so on. And then coming down, it will be 2, 2, oh, excuse me, it should be 2, 1, 2, 1, 2, 2, 2, 3, and so on. Okay, so that's what we're looking to emulate here. So let's not try and do everything at once. It's always better to try and break things down by task. So let's first take a look at simply walking either the row or the column. And let's code that in our Go button here. Okay, so let's have an integer, and we'll call that row. What row am I on? And we're going to be 1 based. We could start counting at 0. A lot of times in programming, we start counting at 0. In this case, I'm going to start counting at 1, and that is because the list box starts at 1. The first element in the list box, for some curious reason, is 1. So many elements in collections in Visual Basic and other programming languages start at 0, but for some reason, the list box starts at 1. So let's just start at 1, kind of a natural thing for the way most people count. And then let's do the same thing with our columns. And then let's use a counted loop. So for row, we'll walk it by rows, equals 1 to 8. And then let's see. Every time we come to the beginning of a row, let's have a string that we're going to collect all the text to be displayed, all those brackets and numbers in there. And so let's come up here and also declare, and we'll call it row string. And we'll start it out as the empty string. Okay. Another way to do that, if you like old school, is to set it as quote, quote, is also a way to express the empty string. But let's go ahead and use the new, more modern nomenclature, string.empty. Okay. And leave a little room there because we're going to enhance this. And what we would like to do is take that row string and take whatever's in it currently, which is nothing, and add to it an expression. Let's see. We'd like it to end up being something like, looking like that, right? Only these variables are going to change. It's not all going to be 1. It's going to be something and something. So let's take and build that expression. So we want a square bracket, and then we want the row variable, and then we want a string literal of a comma, and then we want the column variable, and then we want the closing bracket. So that'll build that expression dynamically for us. Let's take a look and see. Well, right now, the output's not really going to do much for us because we need to have the output displayed. So how about we put this here? Try it there. In my list box, the list box, I named it LB output. Items, add row string. So put that column out there. And let's run this and see what that looks like. Okay. So kind of messed up there. a little bit. 1, 1 is always in the right place, then 2, 1, and 3, 1. Notice that my columns, I haven't started incrementing my columns, but I do see that as it's growing, 1, 1, 1, 2, 1, 3, 3, 3, 1. Okay. So how about if we move this statement for the output out here after the row is built? What does that get us? So there we are. We've populated just the first row. So that's one row. That's what we want to do. Then we need to repeat this for the second row, the third row, the fourth row, the fifth row, sixth row, seventh row, eighth row, and then stop. Okay. So I have this loop this counted loop seems to be doing what we would like it to do. All right, so let's go ahead and clean that up a little bit. We don't need this extra space in here. And what we'd like to do, that's the subtask, that's the innermost task, right? So what we would like to do is repeat that task, but have the column change each time it repeats it. So it'll do it one time, it'll run this loop of 8 steps for the first row. Then it'll run the loop of 8 steps for the second row, then for the third, and then for the fourth, and so on until we have 8 rows fully populated across all columns. So let's go ahead and say, let's see here. How about if we, what we're really walking here is the columns. Yeah, let's see that walk in the columns. I think that's really what we're doing, is we're walking the columns the first time. And so this will just change the variable we're using. It's not going to change the output. So there we are. Yes, see, we're walking the columns. 1, 2, 3, 4. The row hasn't changed. The columns have changed. That's correct. So first row, first row, first row, first column, second column, third column. Okay, so now we've got our nomenclature straightened out. Okay, so the innermost task walks across the columns. Now let's go ahead and wrap that in another task. So we even put a comment here. This loop walks the columns. And we could say walks across the columns. And then we need a loop here. This loop walks down the rows. And let's go ahead and put that loop in. So 4, and it's going to be row, right? Equals 1, 2, 8. And we need to completely contain the inner loop. So see how these line up here, 4 in the next, and it's entirely contained inside, one loop inside the other. Okay, so when we start to walk down here, let's see. Every time we start a new row, what we would like to do is make sure that that string is nice and empty. So we better take row string and set it back to empty. So it starts each new row fresh, doesn't have anything left in the string that we were using. We're going to build the string for the row fresh each time. It walks out the row, and then what does it do? We need to now to move this back up within the outermost loop, but not within the innermost loop. It's not going to do any output until it's got the whole row built. Then it will output, then it will go and do the next column, or the next column walk, as it were, and print that out for the next row when it's complete. And let's see how that's working. There we go. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, and then 2, 1, 2, 2, 2, 3. So we're walking it each element, each cell, each checkerboard square, one at a time, from left to right, from top to bottom. Okay. So very good. There's our nested loops. And just for emphasis, let's go ahead and take this and shut it off. If we shut it off halfway, so we walk it 1 to 4 on the rows, what does that look like? Okay, so we got the top half of the checkerboard visited 1, 1, 1, 2, all the way through 4, 7, 4, 8. What if we do it the other way around? If we walk to 8, and then, but we only walk across to 4. So we're walking down to 8, but across to 4. Let's see what that looks like. So we just stayed on the left half of the checkerboard, but we walked down all 4 columns on the left-hand side. Neat. So it's good to play with this stuff. I encourage you to do so and help cement your understanding. All right, I think that does it for a counted loop wrapped in another counted loop, and kind of shows why we would like to do that and how we do that, and that we have the loop is entirely contained, one inside the other. You don't have parts of the loop, intersecting and part outside of the containing loop. It needs to be fully contained. We can also take a look at one other thing that will give us an interesting kind of insight into this, and that is how many cells were generated when we do 8 by 8. A loop of 8 things inside a loop of 8 things. Run that, and we see that there are 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4, 5, 6, 7, 8. 8 by 8 is 64. Hey, does that work as a rule? Let's go ahead and try it. So let's pick that back to, what if we made it 3 by 5? 3 by 5 is 15. Does that hold true? 1, 2, 3, 4, 5, 10, 15. Hey, so it does. So a loop inside a loop, we can figure out how many times the innermost of the innermost loop, how many times that runs by multiplying the range. So this was the range was 1 to 3 is 3 things, and 1 to 5 is 5 things. We need to add 1 to it. Remember, if we made it 0, right? So that would actually be 0 to 3 is 0, 1, 2, 3. That's actually 4 things. So that would be, if I run this, we're going to generate 24 times 5 things. So you got to watch that for the 0. Remember, if there's a 0 in the range, your total range is 1 more than you're thinking that it is. And let's go ahead and see that run. So 1, 2, 3, 4, 5 by 1, 2, 3, 4 things is 20. And so 0 to 3 is a range of 4. And let's go ahead and put that back, save our project, run it one more time to see that it's working correctly. Let's put this back to 8 because we want to walk our whole checkerboard. And go. And there it is. All right, that's it for this time. I hope you enjoyed the video, and I'll see you next time around. This concludes the lesson.